reminder for our chemistry class, you just took a molar mass quiz last Friday. You're going to take another one tomorrow, which is the 24th of March. Molar mass, another quiz tomorrow. Then you're going to be taking a quiz on this on Wednesday the 25th. So just a reminder of that. Let me just go over a couple of things here. We are working with gas laws, which means that we are using the variables, which is pressure, volume, temperature. You'll notice once again, PVT is pressure, volume, and temperature. You have to be familiar with the units that we are using. For pressure, you will use atmospheres, torrs, kilopascals, millimeters of mercury. Once again, that is ATMs, torrs, kPAs, millimeters of mercury, mmHg. Whenever you see any of these four, remind yourself that this is for pressure. Then, when working with volume, for this particular instance, I'd like for you to use liters, always liters. So if for whatever reason your problem has, whether it's cubic centimeters, cm3, or it has milliliters, just remember to convert over to liters. The simplest way is to move your decimal to the left 3 times. If you move your decimal to the left 3 times, you would have converted that. Then T is for temperature, and in the lab setting or in a science class, we would always use kelvins. For the most part, it should be given to you. If you need to convert kelvins, you would use degrees Celsius plus 273. That would give you kelvins. You add 273 to your Celsius scale, and that would give you Kelvin. Remember that your answers must be in these units if you are required to solve any of these 3 for the gas laws: pressure, volume, temperature, atmospheres, torrs, kPAs, millimeters of mercury for pressure, liters for volume, kelvins for temperature. Then we're also familiar with 4 of the gas laws we've covered so far. The best way to remember this is that my pressure and my volume, both of them are numbered with 1 and 2. My 1 is always on the left, my 2 is always on the right. Once again, pressure and volume, my 1 is on the left, my 2 is on the right. You'll notice P1, V1 equals P2, V2. Whenever they are that close next to each other, it means you are multiplying them. So pressure 1 and volume 1 are being multiplied. Pressure 2 and volume 2 are also being multiplied. Same thing for pressure and temperature. You will notice so that my temperature 2 comes first, then my temperature 1. These are still being multiplied. Pressure 1, temperature 2, pressure 2, temperature 1. That is my formula. Remember that temperature 2 comes first, then temperature 1. Here we have volume and temperature. Same scenario. You will have temperature 2 first, then temperature 1. Then you have your combined gas law, which means you would be putting 3 of these into the formula. You have pressure, volume, temperature, pressure, volume, temperature. Again, T2 comes before T1. My first step in solving for gas laws is always figure out what it is that I'm solving for. If for whatever reason it says what is the initial pressure, what is the initial volume, then you would be solving for either P1 or V1. If it gives you a scenario where those are mentioned, but then it asks what would be the pressure, what would be the volume, you're probably solving for pressure 2, volume 2, same thing for temperature. You have to make sure you realize what it is that you're solving for first. Once you know what you're solving for, then you can figure out which one of the formulas I will be using. Once again, find what it is that you're solving for, then conclude which formula am I going to use. Here I have 2 examples for you. These were in the worksheets that I gave you, and you can locate them on the worksheet. You'll notice that the first step is to rewrite my formula. Once I figure it out which one I need to use, I'm going to rewrite it. I put it up here, pressure 1, volume 1, temperature 2. If all 3 of them are put into this, more than likely I will be using my combined gas law. So because I am using my combined gas law, I rewrote it up here. Although it's small, I rewrote it. We got pressure 1, volume 1, temperature 1, pressure 2, volume 2. Notice how I'm solving for temperature 1 all the way at the end. That is what I'm solving for. You can treat that as solving for X, like in a math class. So what you do now is, if you're solving for that side, I need to make sure that everything else is moved over to this side. So first and foremost, I'm going to multiply in order to isolate my T1. So I'm multiplying 125 times 0.125 times 348. Once again, 125 times 0.125 times 348. I'm going to solve the entire left side first. This has been converted. On your worksheet, you'll notice it has 125 milliliters. We will not use milliliters. You have to convert to liters. So what I did is I moved my decimal to the left 3 times. Move my decimal to the left 3 times. So that's where I get 0.125 liters. And multiply these 3 across, I'm going to get 5437.50. 5,437.50. The units will cancel each other out. You'll notice that the kPa and the liters on this side will cancel out with this side. So you don't have to stress yourself out with writing out the units. They will cancel each other out. Then I'm going to do the same thing on the right side. So I have my equal sign. I already multiplied these across. 100 times 0.1 is going to be 10. And you still have your T1 that you're solving for. This is what is left. I multiplied these 3. I got this as my answer. I multiplied those 3. I got this as my answer. My final step would be to divide in order to leave T1 by itself. I'm going to divide by 10. What I do to one side, I have to do to the other side. So again, 5437.50 divided by 10 in order to leave my T1 by itself. Then I'm going to get 543.75. And since I'm solving for temperature, my unit for temperature is always Kelvin. You'll notice that if you were to multiply these two, carry your units over on this side, and carry these units down here, they would cancel each other out when they would divide. So in order to avoid extra work, don't worry about the units. Just remember when you get your final answer, which is T1, I want to have the correct unit, which is Kelvin. This is the second example, very, very similar. It's also in your worksheet. We have 600 millimeters of mercury. Although this is different than kilopascals, we do know that it is a unit of pressure, millimeters of mercury. This is why we chose this example. So this is my first pressure, once again, P1. Then we have liters. That's automatically volume 1. I am solving for temperature 2, so I'll leave that alone. This is millimeters of mercury once again. This would be my pressure 2. I have liters again, that's my volume 2. And then I have K, which is temperature. That's my temperature 1. Remember, temperature 1 is always on the right side of my equal sign. Temperature 2 is always on the left side. Same thing is going to happen. I'm going to solve for both sides. This time I have my variable on the left, what I am trying to calculate. So I'm going to multiply 600 by 2.5, 600 by 2.5, and that's going to give me 1,500. Equals, I'm going to do the same thing over there. 760 times 1.8 times 295. 760 times 1.8 times 295, and that's going to give me 403,560. 403,560. This is a comma. And once again, I am solving on this side for temperature 2, so I'm going to put T2. This side's already solved. These 3 are multiplied. These 3 are multiplied. I'm solving for T2. Final step, once again, is I'm going to divide. I want to leave T2 by itself. So I'm going to multiply this side, 1,500, in order to cancel this out. I'm going to do it also on this side, 1,500. 403,560 divided by 1,500 is going to give me 269.04. And I'm solving for temperature once again, and that is Kelvin, 269.04 Kelvin. That is my final answer. Remember that you're not always going to solve for temperature. Sometimes your variable will be P1 or V1 or P2 and V2, but it's the same process. You want to isolate it, so therefore you have to move everything to the opposite side by multiplying and dividing. Last tip, once again, always give me your answers in 2 decimal places. Although the calculator could give you multiple numbers, 3, 4, 5, 6, you always round to the second one. Make sure you always give me 2 decimal places. If the calculator only gives you 1, you add a 0 at the end in order to maintain consistency. This is based on combined gas law, which is this final one. Sometimes if pressure or volume is constant, which means it did not change throughout the problem, you don't have to worry about incorporating that at all. If it says constant, if pressure remained constant, volume was constant, temperature was constant, you don't have to worry about putting that into your formula. You would choose which one of the other three you would put into this particular problem. Once again, look for the word constant. If that occurs, you use a different formula. Constant means it did not change. They would cancel each other out in your formula. Remember, to isolate, use the correct units at the